Hello, my name is Aisha Jang. I'm a sophomore at Clark Atlanta University, and this is for my organic chemistry course at the University of New England. So we have this compound here, we're giving the molecular formula of C10H12 and one oxygen, which is also known as the compound ethyl butyrate. These are the graphs that we are given for it. So at the frequency of 2950 to 2850, we have one single carbon hydrogen bond, and it's at sp3. It has the alkane I chain formed. And then at the frequency of 1750, we have one double bond of carbon to oxygen, and the ester group is meaning the ester group is present. At frequency one at frequency 1190, we have one carbon oxygen stretch. And then for the chemical shifts, we have at 174, we have a carbon double bonded to an oxygen, and it's a quaternary carbon. At chemical shift 62, we have an oxygen which is bonded to a carbon, and that same carbon is bonded to two other hydrogens. Because it's bonded to two other hydrogens and it's not three, it's more electronegative. At 36, we have at the chemical shift of 36, we have a single carbon atom bonded to two hydrogen atoms. And then we also see that at 18, we have another carbon atom bonded to two hydrogen atoms. At 14, we have a singular carbon atom as well, bonded to two hydrogen atoms. At 14 and 13 as well, we have that same one singular carbon atom bonded to two hydrogen atoms. Moving on. At chemical shift 1.1, there's an integration of 2.9, and we can tell that it is a triplet because of the echo group interpretation. And then at chemical shift 1.5, we have an integration of 3, the multiplicity of a triplet, and an integration of the alkyl group. At 1.9, we have an integration of 2, and the multiplicity is a sextet. The interpretation is the alkyl group next to the carbonyl. It's not attached to the carbonyl, but it's just next to the carbonyl. And then at chemical shift 2.3, we have integration of 2 and a multiplicity as a triplet, and an interpretation of an alkyl group attached to the carbonyl versus where that 1.9, it was just next to it. At chemical shift 4.2, we have an integration of 2 and a quartet multiplicity, and the interpretation of that is that the alkyl group is actually attached to the oxygen, unlike the previous one where it was attached to the carbonyl, and unlike that one prior to that where it was just near. So this is the proposed structure that I drew. Let me see if I can. Yes, like I mentioned previously, this is ethyl butyrate. It has 1, 2, 3, 4, 5, 6 carbons. Over here, we have it double bonded to an oxygen, and then in the chain, we have actually another oxygen, so that counts for 2 oxygens, and then we have another CH3 carbon structure at the ends, each of the ends. And then for these carbons, so carbon 5, carbon 2, carbon 3, there are 2, that's a CH2 structure, so it has 2 hydrogens on either end. And yes, thank you for watching.